All right, guys, welcome to problem set 117, part 1. What we're going to do today is we're going to learn set builder notation. So this equation looks a little bit weird, but I'm just going to tell you how to read it in English, and then I'm going to tell you how to actually get into a workable problem. So this A equals, that is actually a set, and we can tell it's a set because of these little curly braces. So we're going to say set A is the set where x is an element of the integers such that x plus 2 is greater than 4. So this little e thing is the element, this little bar means such that. So I'm just going to repeat that so you don't have to go back in the video to hear it again. How we would say this in English is set A is the set where x is an element of the integers such that x plus 2 is greater than 4. Now how we normally would do this, we would say x plus 2 is greater than 4, and then we would just say domain equals integers. So it's just a rewriting of something that we've already done. So we should be able to fly through this pretty quick as long as we're okay in how to say this in English and how to pull the needed information out. This part on the end of our such that symbol is going to be what we're actually graphing, and this first part is just telling us our domain. So let's just graph this. First I need to isolate x. So I'm going to say x is greater than 2. My domain is integers. Now when we're graphing this, I just find 2, and I'm going to be graphing all of the integers that are greater than 2. And we're done here. Okay, let's have you guys try one on your own. Notice I've got a conjunction. This is a little bit different. We're saying the set where x and y are elements of the real numbers. You'll notice this little real is squared. That's just telling me that it's two-dimensional. So when I see this little real squared, what I'm going to do is draw my two-dimensional coordinate plane. You should notice that these are both lines. So what we're saying here is I've got y is greater than x plus 2, and y is less than negative x, and my domain is the real system. So what I want you guys to do is try to graph this on my coordinate plane. Take 30 seconds to do that, and then unpause your video to see the solution. Okay, let's take a look. This first line, y is less than negative x. Let's graph it like a normal line. Negative x would have a negative slope, and so I draw it through the origin just like this because there's no y-intercept. So now what we're going to do is graph this equation. My y-intercept is 2, and it's got a positive slope, so we're going to graph it like this. And now we just put our pencil on each line and figure out where I'm going. For this line with a positive slope, y is greater, so that I'm going up. That means either this or this region both satisfy that. But I need to figure out which one satisfies my other inequality. Y is less than negative x, so when I put my pencil there, I need the y's that are less than that, and that tells me that this is the region that I'm looking for. So if you guys were able to get that graphed, really nice job. Let's try one more. Okay, let's just remind ourselves how we pronounce this. We're going to say set B is the set where x is an element of the real numbers such that x squared is greater than or equal to negative 4x minus 3. Now you'll notice this is one of those conjunctions that we've been doing from a previous chapter. I'm going to give you guys 60 seconds to try your hand at graphing this. Unpause your video to see the solution. Okay, what we need to do first is factor this term. So I'm going to put all my terms on one side. I've got x squared plus 4x plus 3 is going to be greater than or equal to 0. And just recognize that my domain is the set of the real numbers. What I need to do first is factor this left-hand side. That will give me x plus 3 and x plus 1 are greater than or equal to 0. And now if you remember, if I have a product of two quantities that are supposed to be positive or greater than 0, they can either both be positive or they're both negative. So I'm just going to set up that statement with math. So I'm going to say x plus 3 has to be positive and x plus 1 has to be positive, or x plus 3 has to be negative and x plus 1 has to be negative. Now we're just going to isolate x in all of these. So this tells me x is greater than or equal to negative 3, and x is greater than or equal to negative 1, or x is less than or equal to negative 3, and x is less than or equal to negative 1. Now, you might remember the trick. If both my inequality symbols are going in the same direction, I can simplify them down into one term. If they're both greater than symbols, then I choose the bigger number, which in this case is -1. Now I verify both my inequality symbols are going the same direction and they're less than symbols, so I choose the smaller one. So I've got x is less than or equal to -3. Now we've got a statement that we can graph on our number line. So I plot -3 and -1 on my number line, and because they're real numbers, I'm going to do a solid dot because I've got this little equal bar and everything to the right of my -1, and then a solid dot and everything to the left of -3. And this is how your graph should look. Okay, nice job on that today, guys. Come see me in my live hours if you're struggling with anything, and I will be able to help you guys. Good luck with the homework.